Okay, so lesson 2.8 is about horizontally and vertically launched projectiles. If an object travels through the air under the influence of gravity, it is called projectile. So any object that is under the influence of gravity and actually also of air resistance, it's called projectile. However, in our case, we will try to assume the effects of air resistance is neglected. So it's only under the influence of gravity. And projectiles can be thrown horizontally or at a certain angle. So horizontally or at certain angles. But the focus for now is just horizontally launched. So I've shown you last time this uh, motion of an object being launched uh, horizontally. So you have a projectile here. So once it leaves the, well, it can be a table or what. Once it leaves this particular table or something, okay? So now it's in free fall. So it is just under the influence of gravity in this case. And if you can see the particle motion of this particle here, vertically, the vertical motion, okay, if you can see, the distance traveled by the object increases, okay? So that tells you that the velocity along y, or the vertical, okay? So in this discussion, I will interchangeably be using the terms the y component or vertical. When I say y component, that is just the same thing as talking about vertical component, okay? So the Vy changes, and this is due to the fact, due to the fact that there's gravity, okay? However, if you can see in the horizontal motion of this object here, well, the distances as it traveled through horizontally is the same, okay, all throughout. If that is the same, if the distance covered, the displacement covered is the same as you move along time, okay, that means that the velocity along x is constant, okay? So you'll get a straight line here, straight line graph. Straight line graph again tells you that the change in the displacement over time is the same all throughout the motion of the object. So that means that Vx is equivalent to constant. So when we say constant, no change in the velocity. And that only means that the acceleration along x is equal to 0. So that's 0 meters per second. Again, when you say v constant, automatically a is 0. So if you're gonna go back to your vertical motion, since you have changing velocity, actually this is increasing. Acceleration along y is negative 9.8 meters per second squared. So actually that's how uh, the velocity changes. Again, if you're gonna graph this one, it is increasing, or although it has a negative value, the negative sign here is actually due to the fact that it's moving down. But the velocity, the magnitude of the velocity there increases as you move down. But if as you move up, actually the velocity decreases, but still the value of the acceleration is negative 9.8. The negative sign indicates that as it moves up, the velocity decreases. Okay, So now the horizontal velocity is again constant, and the reason for that is horizontally there's no external force. Okay, although we'll be learning more that in dynamics portion, the next unit of physics 11. After kinematics, we will be talking about dynamics. So x component of the velocity is initially have some value and does not change. So it wouldn't change whatever is the initial value of your Vx. So that means you can also say that if you have Vix here, it's just equivalent to Vx. So all throughout the motion, the velocity doesn't change. At any time t, the velocity along x doesn't change. Again, this is horizontal. So again, in this discussion, I'll be interchangeably using Vx or the x component or the horizontal component. It means the same thing. Okay. So gravity causes the ball to accelerate downward. So essentially, the negative sign there indicates that that is the direction of your, uh, actually the force acting on the object. And we know that gravity is pulling us towards the center of the earth, so therefore its direction is downward, so causes the ball to accelerate downward. So that's the reason why you have the negative sign. Okay, the negative sign there actually indicates the direction of your net force or the force acting on the object. So vertical velocity increases in the downward direction, usually given as a negative sign. Again, in our case, if we use the Cartesian coordinate system of going up as positive, downward as negative, uh, yeah, positive to the right. So if we use this one, using this convention here, our acceleration would always be negative. So for uh, projectile motion, we also use negative 9.8. And remember that if it is horizontally launched, you have AY and AX. Okay, but AX is 0. So essentially, the acceleration of your projectile motion is just negative 9.8, and that is just due to the y component of the acceleration. Because if you can see here, the x component of the acceleration is 0. So the y component of velocity is inertia but grows bigger and bigger over time. So if it is horizontally launched, this is the case. If horizontally launched, horizontally launch. So your VIY is 0. Okay. So that is the reason why when I tried to show you last time, it's quite important that I drop the ball. I will not be exerting or I will not be throwing it downward. Because if that is the case, again, if you have horizontally launched projectile, the initial velocity along y there is 0. So it's just the same thing as dropping it down. Okay. So projectiles follow a parabolic path. So this is called the trajectory. Okay. This is the trajectory. Trajectory. So the path followed by your projectile is what you call the trajectory. Okay. So again, just remember that for horizontally launched projectiles, it has both Vx and Vy component. So you now have two dimensions there. But try to remember, just like what we did in two-dimensional vectors, uh, y component and x component are independent with one another. Okay. So Vx can only affect the x motion, so the x displacement of the object. and the y component also only affects the motion along the y, or the vertical motion. Okay, so let's take example number 1 here. A cannon is fired horizontally from a 10.0 meter cliff. If the muzzle velocity is 55 meters per second, how long is the projectile in air? What is the range? When you say range, it's just the horizontal displacement. So you're talking about the x component, so the x displacement here. So that is range. So if you're gonna go back to the drawing here, the range is given by this. This is your range. So the horizontal distance it traveled. Okay. So for any, again, as well as for any kinematics problem that we have, uh, it's always good to start your solution with a drawing or a figure. Okay, your drawing is not necessarily that beautiful, but at least you can able to interpret your drawing. Okay, so uh, let's say for example here, this is my Canon. How would I draw my Canon? Uh, okay, you have that. Okay, so it is just horizontal, and then you have here the object or the cannonball. So it moves straight first. Okay, so the muzzle velocity is 55 meters per second. So that means that the velocity once it leaves the barrel is 55 meters per second. Okay, and I'll just gonna complete this one. The height, so the height of the cliff is 10.0 meters. Okay, so uh, those are the two information that I'm given. Initially, it's, yeah, but I know that eventually this will move in this direction, and then, yeah, although not necessarily it should be here. 55 meters per second is quite fast. So maybe this is um, like not necessarily drawn into scale. Okay. You have the two questions here. First one is how long is the projectile in air? So that pertains to time, and the range. So you're solving for the range. So you have two questions here. So the strategy in solving projectile motion, you try to separate at least the things that you know. So you try to make a table, like I'm gonna place everything what I know in one side for my horizontal motion. So this means the x, and then the other side would be everything about my vertical motion, or the y. Okay, so you have horizontal along x, and then the vertical. Again, it would be helpful if you're gonna separate them, at least the things that what you know. So for the horizontal motion, what are the things that you are given here? Well, is it not that initially the object is being launched horizontally? So that means that that would be my VIX, which is just equivalent. I know that it wouldn't change. So VX at any time is just equivalent to 55 meters per second. And as we have mentioned earlier, if it is horizontally launched, VIY is equal to 0. So that means that in this case, the initial velocity along y is 0. Because again, it is launched horizontally. And if you can see there, if it is launched horizontally, the y component of your velocity is 0. Okay? And then, well, since the velocity is constant there, the acceleration along x is 0. How about in my vertical component? The acceleration is always negative 9.8. Okay. So again, going back to my coordinate system that I use, again, that's negative because I use the Cartesian that upward is positive, down is negative, this is positive, and then this is negative. So I also mentioned this one last time that you always set your initial position to 0. Okay. So let's say your initial position here, that is your 0 meter. So if you're going to go down here, what would be the position of the object vertically downward? Well, is it not that this should just be negative 10.0 meters? Again, the position of the object below. Again, we use that coordinate system. That's why we use the negative 9.8 meters per second here. Again, essentially because we are using this coordinate system, like upward. So therefore, at the middle, that's 0. So if you can see, you move downward, 0 is at the starting point, and then you move down. So that means that dy is negative 10. Okay? So that means that dy here is negative 10.0 meters. Okay? And well, for both cases, time is unknown. I don't know the time. As well as my dx, it's question mark. Okay. So now, if you can see, my vx of 55 meters per second, I can use that one for anything that I want to solve for the quantities that is along x, or the horizontal motion. The other side, the right-hand side of my table, these are the things that I can use to solve for anything that I want to know along y. If you can see here, my t for both, the time for both, I am not using tx or ty. The reason for the time being is that this is the variable that you can use for both. Okay, so whatever the time that I get here, that is also the same time. I can also use that one on the other side. So that's the only quantity that I can use, the time component, or the time variable. So this t here, again, I can use that one by t on the other side, because if you can see here, I'm not using tx or ty, I'm just using t. So therefore, this time, if I'll get a particular value on this side here, I can use that one on the other side also. That means that that's also the time upon which it, well, for example, in this case, for letter A, I want to solve for how long is the projectile in air. So that particular question, that is the same thing as the time of flight. This is the time of flight. So that means that I'm looking at upon which it reaches here, how much time does it take to reach this particular position here. But if you can see, this particular position has two components. This would be my dy, okay, and the other one is my dx. So remember that in your 2D vectors, you can represent this position here in terms of the x value. So you move along the x and then along the y. Okay. So for the first question, I'll be solving for time. Here's the thing. In your displacement equations, you have their different displacement equations. So the displacement equation that we talked about last time can be used for this type of questions. So it's either you use that one in your vertical motion or the horizontal motion. Okay. So to solve for the time here, if you can see, uh, I think if you're gonna examine all the three equations there, you can use either of the three equations if at least three variables are given. Okay. If again, if you have not noticed it, but if at least three quantities, if at least three quantities are given, you can use the displacement equation. Displacement equation. So just choose the right one. We have three. We talk about three there, but just choose one that somehow will fit on the things that we have. Okay. So I will not be looking at my horizontal motion because if you can see here, I've only given two. One and then two. But this one here, if you can see on the other side, I have one, two, three. So therefore, I'll be focusing on my vertical motion, the things that I know in my vertical motion because I have three given. The horizontal motion, I have only two. So in the vertical motion, again, three quantities are known. Okay, three quantities are known. This one here, I only know two known values. So therefore, I'm gonna focus on my the things that I have in my vertical motion or in my y component. So based on the things that I have, which of the following can answer the question of how long? So if you're gonna examine on that, you should be seeing this expression here. Again, specifically instead of d, I use dy, vit plus 1/2 at squared. So if you can see here, this is biy. So specifically, so the changes that I made in this displacement equation is that I just changed the subscript, or I place a subscript just to denote, because again, I'm not talking about just the uh, displacement, but specifically the displacement along y. So I use the subscript. So don't forget to use the subscript there and the ay also, just for you to be guided. Okay. So if you can see, I use the different uh, subscript, and that is all along y, the vertical motion, because I'll be using this. I'll be using this to answer the question of time, because if you can see, I have dy, I have viy, and I have acceleration. The only unknown in this equation here is the time, which fits well. Again, in an equation, you can use that equation if there's only one unknown in that particular equation. So you can solve that unknown. So now I'm just gonna substitute. So dy is negative 10, viy is 0, so therefore this is 0 because viy is 0. So this is just 0 plus 1/2 of ay is negative 9.8. Okay, and then t squared. I don't know the t squared. Well, if you can see here, if you're gonna try to solve it this way, if you can see, well, the only unknown is the variable t, which again, I'll be happy about because I can solve for that. Okay, you'll have a problem if about plugging in all the things that you have two variables in your equation. That would be a problem. But in this case, well, you only have one t as the unknown. So if you're going to solve for t, that's negative 10. This is negative 4.9. So this one here, if you're going to divide that one out, that gives you negative 4.9 t squared. Okay. So solving for t, that would be, well, I need to divide this one first by negative 4.9. So that is t squared is equal to around 2.04, and then I'm gonna take the square root of both sides. Again, I know that when I take the square root, it's a plus or a minus, but since this is time, I'll be taking the positive value. So that's around 1.4. So that's 1.43 seconds as the time, 1.43 seconds. So this is how long that the projectile will travel from this position down here. Okay. Now, again, as I've mentioned, whatever is this time here, you can use that one on the other side. So whatever is the time here, that means that along x, if you're just gonna take note of the horizontal motion of the object, it will also reach here at that particular time, 1.43 seconds. So therefore, I can use that one. This is 1.43 seconds also. Again, you have 1.43 seconds as your answer of how long does it take to reach that particular position, downward displacement of negative 10 meters per second. Now, if you can see here, with additional information of the time, I now have three of the quantities known, and I want to solve for dx. So again, this is now talking about dx, or the x component of my projectile motion. So if I want to solve for dx, again, I've given the time, acceleration is 0, and vx or vix, or again, the velocity along x doesn't change. So therefore, I can use the same equation. Dx is equal to vxt plus 1/2 at squared. And if you're going to substitute everything up, if you can see here, this is 55 times 1.43 plus 1/2, and 0 time is 1.43 squared. Well, if you can see, this particular term here in your equation becomes 0 because acceleration is 0, so 0 times whatever that number is 0. So it just reduces to just the Vx and T. So which is 78.65, or that is 79 meters. So therefore dx, or the range, is 79 meters. So this is the range. Okay. So the equation just reduces to just the simple equation of Vix times t. And everything there is actually, yeah, reduces. Acceleration is canceled out because the x component of your velocity initial or the acceleration along x is always zero because it doesn't accelerate there. The acceleration only happens in the vertical motion. Okay, so are there any questions before we proceed? Yes, Andre?
Yeah, I just want to ask, like, will there ever be any like a conflict between like range, meaning the horizontal displacement, and then range as in y values?
Uh, like what you mean
Range means like all the y values.
the y values? Well, all the y values is only affected by your VIY and your acceleration along y. The Vx doesn't affect that.
No, I know. I just meant like, is it so that like will the range ever talk about like the the y values ever? Because like I know in math it does. So just wondering.
Well, if you're asking if maybe you're talking about the essentially the position of your object, like the dx squared plus dy squared, like the maybe the diagonal distance. But usually in our case here, we try to give the position of the object in terms of your x value, dx, and the dy. But if you're thinking about like the essentially the position of this one here of the object, the position of the object can be written as uh, because if it's stuck around the this one here, the velocity could be somewhere at that direction. Okay. Although the usual question here though is what would be the velocity of the object upon hitting the ground? If that is the case, you're actually getting the magnitude and the direction of this object, which upon which the magnitude of the velocity is a combination of both Vx and Vy. At the same time, if you're talking about its position r, or position of the object, it should be consist of the magnitude of your r plus the direction. But same thing as what we did in your two-dimensional motion, to get the magnitude of the position, it's actually affected by both dx and dy. And for the direction, you need to, well, the usual case is the basis is the horizontal. So you solve for theta there. Theta is just tangent inverse of, you have here dy over dx. Andre, hopefully, is that what you mean? Like,
Not really, but I think I just thought about it. It's fine. It's all good. So,
okay. Yeah. Just thinking about like how is dx affected is by dy. Well, again, if you're gonna ask for the position of the object here in terms of the direction and its magnitude from the initial position, you can solve it this way. Or the usual case is that if you're gonna find the velocity of the object before hitting the ground, you need to solve for both Vx and Vy. Well, I know that the velocity along y here would be not equal to zero. but I'm sure that the velocity along x here is always 55 meters per second. But I'm just gonna erase this one here. Are there any other questions or clarification here? I know that sometimes it's quite hard to, yeah, separate these two motion, but the reason why you need to place that one in the table so that you'll have that sense that, okay, these all things here, VIY, AY, and yeah, these things pertains to my vertical motion. The other side pertains my horizontal motion. The one that you can use between the, or you can cross over between the two is just your time, just your time. Okay. Any other questions? None. So we can move on to the second one here. So a ball is thrown horizontally from the top of the building at a velocity of 6.5 meters per second. If the object takes 7.5 seconds to reach the ground, how high is the building? How far from the base of the building does the ball land? So again, it's always good to sketch your problem first. So if I have a building here and yeah, you have a person throwing something, okay? And remember that it is thrown horizontally. So your VI here is 6.5 meters per second. And well, if you're gonna throw that one out, you're gonna, well, it will not move in a straight line, but somehow in a parabolic form. The trajectory of your projectile will always be a parabola. So it reaches the ground here. And the time upon which it reaches the ground is given by 7.5 seconds. Okay. So this is the time of flight. You can think of that one also, time of flight. Uh, so this is your dx here, or just the range. And if you can see, based on the question, the range is actually the second question there, your dx. How far from the base? The base of the building is this one here. This is the base of the building. So how far from the base of the building? Well, that would be given by the range. And then how high is the building? So remember that this is your dy here. Okay. So although the question is just the height, when you say how high, it's just the magnitude. Just talking about the distance. So this is just asking for the distance, vertical distance. So that means that you're just looking at the distance between the base and the topmost of your building. Well, this is assuming, okay, the drawing. This is assuming that, well, this is thrown at exactly at the top of the building. So uh, now, at least that is the first question. So again, as I mentioned earlier, that you need to do a table just to indicate the different quantities. You try to separate the things that you know in the horizontal motion and the vertical motion. So horizontal motion here, the VI, the initial velocity will be, well, it's slant horizontally, so therefore that would also be my VIX, which is also my VX, which is 6.5 meters per second. And again, if it is horizontally launched, your initial velocity along the vertical line is always zero. The acceleration is zero here, but the acceleration along y is always negative 9.8. Again, taking note, the coordinate system that we use is the Cartesian coordinate system that we are known of. And what else? The other thing is the time. So time is given as 7.5 seconds. And again, that is also the same time for my my vertical component. Again, there's no distinction between my time along x or along y. So they are the same. So I can use that particular time. Okay. So the unknown in one side is my dx. I don't know what is the displacement along x here, as well as the displacement along y. So that's also a question mark. So now, to answer the first question, it asks for the distance. But is it not that the magnitude of my displacement is just pertains to the that vertical distance? Okay, for a while, it should be Google or Physics 11, and then yes. You can? I don't know. I think, are you using your SynPats account? That's weird. You should be able to join. Yeah, maybe after this example here, we can have a break and then, yep. Okay. Okay, going back here for letter A. Since I want to solve for the vertical distance, so for letter A, I'm trying to solve for the vertical distance. So it should be, I'll be dealing with the things that I know in my things here, okay? And the vertical distance is related to my dy. So therefore, I'll be using an equation that can solve me the value of dy. And that is just given by VIYT plus 1/2 AT squared. Automatically, VIY is 0, so therefore this is 0 here. So dy is equal to 1/2 of 9.8, negative 9.8. The time is 7.5 squared. And if I gonna solve for that one, that gives me negative 276 meter. But remember that this is the displacement, or at least the position of the object. And if you can see, that also jive in with the question, because with this coordinate system that we use, this is my 0 meter position. So therefore, it's below. So the negative sign only indicates that below the initial position. But then again, position. But then again, for vertical distance, it's just the magnitude. So therefore, I would say height is equal to, I think 2 sig figs. So that would be 280 meters. Okay. So I disregard, again, it's asked for the height. So height is just a uh, uh, scalar quantity. So I can just disregard the negative sign there. But again, knowing the position of the object after 7.5 seconds also somehow answers the question of how high the building is. Okay. So B, for letter B, you can still use the same equation. So everything is given except for dx. So you have dx is equal to uh, vix t plus 1/2 at squared. But then again, since acceleration is 0, so a is 0, so therefore it's 0. So essentially, for the equation of motion, you're just dealing with vix and the time. So you have here dx is equal to 6.5 multiplied by 7.5. So dx is equal to around 49 meters. So therefore, the range is 49 meters. So that's how far the ball is from the base. So the usual question in our case is that we don't necessarily find the distance it covered by the object, because if you want to get the distance covered by the object, it should be the trajectory, but that's a parabola there. Usually the question is related to the vertical distance it covered and the horizontal distance that it covers. Okay, so any question with the second example?